against playlists, right? So the first thing you would do, you'd say, okay, well, I'm going to create this playlist fixture, and I'm going to create, I want some videos in my playlist, so I'm going to create a video fixture, and then add that video fixture to the playlist, right? And then you would run your tests against that. So that was kind of a nice concept because it had a lot of configurability, right? So presumably, you could write tests in all sorts of different combinations, like, oh, I want a playlist with 20 videos and not 5 videos, and you could do that within your two-stressor test. But the caveat is that if the API was already implemented, yes, it was easy to write tests. But the problem was that implementing this fixture API was pretty complicated because the way it actually worked behind the scenes is you were building up these responses, in the client, in the two-stressor framework itself. So the way it would work, it would read in sort of these inner tube kind of base golden responses, and then there was all this response builder logic that would read in those, and based on what you had configured in your fixture API, try to build the response for you. And the problem was is that these inner tube responses, they're pretty huge. Anyone who has ever gone in and tried to make sense of them can tell you that. And different classes were talking to different inner tube endpoints. So there's like a browse service, search service, so forth, right? And so for each of those services, we had an equivalent one in TubeStressor that extended. So you'd have a fake browse service and a fake search service. And this is what the response builders talk to actually feed in these responses. So this had two main problems, right? One is that we weren't testing as much of the app code as we could, right? You can see here on the diagram, the inner tube service layer and the network layer were actually not being tested, and there was a couple bugs that escaped, because of that reason. And the second problem, it was kind of a maintenance issue, right? Because we have all these extensions into the app, like 30 or so, and we have to deal with how to inject all of those fakes into the app, and it was pretty complicated, right? So we said, okay, how can we improve this? So this is basically what the new architecture would look like. So the first thing we looked at is like, how can we simplify the API, right? So we decided to go with sort of a simpler, kind of more bare bones API, which is called our network response API. So instead of using fixtures, what you do here is you basically just set up responses for requests at the network level. So you can basically say, okay, when you see this given browse request for this given browse ID, return this golden response directly with no sort of manipulation. And if you need responses in different forms, that's when you actually go to inner tube tests that are responsible for generating this. Because in those inner tube tests, you have the same sort of control you used to with the fixture API. It's a little bit rougher, but at least it's generating the responses in the domain that they're meant to, right? You don't really have to understand the structure there to write those tests. And the second thing we did is we improved actually how we were injecting those responses, right? So instead of overriding sort of at the inner tube service level, we actually override the network level. So we kind of plugged in this network interceptor that was sort of on the lowest level we kind of get in the network stack. And this is the thing that's sort of going to listen to all the network requests that are coming in and intercept them and actually return in whatever kind of network response you want. So there's a few advantages we think of this new too many steps, right? And this is especially acute for iOS developers, and I'm going to explain why. Here's sort of a sample workflow. We wrote a developer journey is kind of the new buzzword. We wrote a developer journey for a TubeStressor test, right? So we looked at all the steps. What does it actually take? So if I'm an iOS developer and I previously wanted to, let's say, write a TubeStressor test for a new feature, TubeStressor used to have this single source cross-platform API. So you write the API in Java, and then you transpile it into Objective-C. So in order to do anything, if you want to test a new feature, there's a 95% chance, maybe 99% chance that you'll have to define new API. So they first have to switch to the Linux environment, define the Java API, run the Blaze /script to generate the Objective-C stubs, and then they actually have to get approval from a limited set of TubeStressor API owners. And maybe we don't like their API, and there'll be some back and forth and whatever. Right? So the next thing they do, okay, so then they have their API. Then, they wouldn't always need to do this, but in a lot of cases, then they might need a new inner tube test that needs to generate a new golden. So they have to modify the inner tube test. There'd be a script that would generate the golden, and this golden would sort of be in a server format. And then they have to get approval from another set of inner tube owners to actually submit their changes. And then the client, the mobile app, couldn't directly consume the golden in the format it was generated. It first had to be converted into a different format, this client golden format. And there was this I think, post-submit job that would do that, and typically you might have to wait 2 to 3 hours for this golden transformation to take place. Then finally, you can start to actually get into the guts of writing your test. You would switch to Mac environment. You'd implement your API using Earl Grey, which is a UI testing framework for iOS. And then finally, you can write your test. And after all this, writing the test is pretty simple. But it took you all the steps to get there. So how can we improve this? This is what we looked at. There's sort of 3 main things that we did. We kind of took a hard look at this cross-platform API. Again, talked to, when we went and talked to all the developers, we kind of asked them, like, is this useful or not? And what we found is that even though in YouTube, all the mobile teams are kind of organized around a product line, so there's a main app team and there's a kids team. But all the individual developers, they either work on Android or they work on iOS, and very, very few of them actually work on both platforms at the same time, right? And even though there's rough kind of feature parity between the different platforms, sometimes the features are done out of sync and in different areas. So, we weren't really taking advantage of the fact that TubeStressor did support this single source API, and hypothetically you could write a test once and run it on multiple platforms. So we decided to stop doing that. So instead what we're doing is we're having a platform-specific API that teams can manually choose to keep consistent, if they wish, right? And because the API is pretty simple, it's actually not that hard to